Hello, guys. I just want to give you a short presentation of the current state of the new debugger. Just focus on the right side first. As you can see when I refresh here, I'm actually creating the new debugger using Cerebral and the old Cerebral debugger, and it's a really funny concept actually. So what we see here is that when the client, and this is faked, like simulated. So it just simulates that it receives a payload from the actual application, and then it checks what type of payload it is, and this is an init payload, which runs something called set payload. So what it does is that each application will have like its app ID. Um, that lets the debugger handle multiple applications at the same time. And this is just, we can just use like a random number with the current date or something. That isn't so important, but you can also see that it passes in the version here. So now Cerebral will tell the debugger which version it should load, and that's really, really nice. So what it does here is that it sets the payload on the app registered, and then it actually runs the mutations on the signals passed. And I'm going to talk about this. And then it just sets the current index on the signal that is received. So let's just remove that so we have a clearer view of the actual debugger. Okay, so like the design I've been doing here is making everything align. So it kind of so it looks good. Let's see, it should look something like that. The icons and stuff like that, I have not given it much thought. But let's go through this. Okay, so we have our signals list on the left side, and we still use colors to identify a specific signal, which will help you as you develop your application to more easily identify the different signals. And it states how that signal was run. It also indents signals that has been running within the same execution. Maybe we should do something a bit more clear, but that's how it works right now. And then we have the actual signal here. So if I change, we can see that. And as we can see, we have the input, and I've actually built my own object inspector. So this is an empty object, so it doesn't show much. But as we move down here, all these values here, even the state values, like you set when you mutate the state, are using this object inspector. So like I just call it the inspector because you can pass it any kind of serializable value and it will just return it. Anyways, here we can see that, okay, we have an object and it lists the keys of that object, which I think is beneficial. Like you want to see what is being passed, but if you click it, you have more information about the values as well. And it's the same on the output. And this works pretty well. I really like this. I'm sure we can do changes to it in regards of coloring, colors and stuff. But yeah, I really like this. Um, and so yeah, so things are structured like you see here. This indicates that there are some parallel stuff going on. And this save to do gets an input and an output, and then moves over to a success and not an error, and all that good stuff. Okay. Mm, yeah. So there's nothing much more to that. But then we have the model, and this is really cool. So what happened now is that when I got the payload, let's see, when I got the payload, it had an initial model. And this initial model is whatever is in the state store when the application fires up. And this is stored inside the debugger. And then the debugger will actually produce the state of the model itself. So we won't pass the model on each change inside the application. We will just pass the latest signal. And then the debugger will figure out what mutations it needs to run to bring the model up to date. So that is what happened down here. Here we ran all the mutations on the signals that has currently been run, and that has updated the model. So it's the same in the debugger as on the application. And the reason we do this is to pass less data to the debugger. We have had some problems with passing too much data, and it will be really problematic if we were to pass the whole model on each change. So I feel that's solved. But now, the really cool thing now is that we can put this, so this is the same object inspector thingy. But what we can do here is I can click this title and I can just change it. And what happens now is that the model, of course, changes inside the debugger, but the debugger will fire off an event to the application, which will also update the model layer there. So that means that you can sit with the debugger, look at your model layer, and as you do changes to your application, you will actually be able to see live updates inside the model in the debugger, and that's really awesome. But not only that, you can at any time just change some value, and it will update in the interface in your application. And this is really, really awesome. It's cool, like a technical cool thing, but I think it can also prove itself to be very beneficial. Um, all right, so that's basically what I wanted to show you. Alexi has done a great job on refactoring Cerebral, so now the dev tools and the signal store are just modules, which makes it easier for me to refactor to this new debugger and make them talk to each other more effectively. So that's really awesome. Okay, I will let you know when things are connected and I can show a live demo of the new debugger. Thanks.